Hello, today we are going to be answering 4 questions. The first question here has 2 parts. So the first thing we're going to do is explain the difference between the set of natural numbers and the set of whole numbers. This is really important for what we're going to be learning following this. So we have our natural numbers versus our whole numbers. So for our whole numbers, they're actually going to be are numbers that we count. So they are counting numbers. So we use this when we count objects, maybe people, things like that. So with those numbers, we have 1, 2, 3, 4, and so on. Forgot a comma there. And then over here on our other side, we have our whole numbers. So whole numbers include all the natural numbers plus 0. So for that, we are going to have 0, 1, 2, 3, 4, and 5. And this also is going to continue on. So like I said, now whole numbers include all of the natural numbers. And we are also going to add 0. So instead of starting at 1, we are going to start at 0. So a set of whole numbers, like we said up there, we are going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. So what does closed mean? Closed means that when you add 2 numbers from the set, your answer will also be a number in the same set. This is going to be part 2 of our question, is a set of whole numbers closed under addition? And we are going to be giving an example why or why not. So we have our definition here. So knowing this, we are going to now use counters. So we have 3 counters here like I drew on the side beforehand. Usually we'd use manipulatives, but we are on our iPad today, so now we're going to add 4 counters and that drawing there, which is going to equal, of course, 7, because we have 1, 2, 3, 4, 5, 6, 7. And I'm going to go ahead and color these back in, and this equals 7. And so 7 is also a whole number. We're going to add that on there just to keep our notes. So now we're going to try a different one. We have 0. So you'll also see this represented as 0 with a cross to it. That just means it's 0 and not an O. And I want you to also recognize that it means nothing. There is no number there. So we have 5. So we have 5 counters. And that means that it's just going to be 5, because 5 plus 0 is, of course, 5. If you add 0 to 5, it's just going to be 5. So 5 is also a whole number. Since every time I added 2 whole numbers, I get another whole number, the set of whole number is closed under addition. Now we're going to be working with 3 plus 4. We are going to be using manipulatives to explain how to add 3 plus 4. So I have 3 counters over here on this side in red. 1, 2, 3. And I also am going to have some blue counters on the other side, and we have 1, 2, 3, 4. Now let's put all of them together and count how many we have in total. So we have 1, 2, 3. I'll be representing these with our red marker. Later down, I'm going to be doing them all in the same color, but this is just to explain it. So then we have 4 blue counters, and that brings us to a total of 1, 2, 3, 4, 5, 6, and 7. So this means that our total here is 7. So now that we worked with those counters, we're going to want to try some other skills like a number line. So let's get our number line here. So I have a number line here marked 1 through 10, so we're going to find 3, and I'm going to plot it here on our number line, and we're going to go 4 spaces to the right. So we have 1, 2, 3, 4 spaces, which both models show that the sum is going to be 7. 3 plus 4 is equal to 7. These are 2 strategies you can use for addition. So for our third question, we are going to use manipulatives to explain why addition is commutative under the set of numbers. So, what is commutative property? Commutative property means that the order of the numbers does not change the sum. In other words, we have, hold on one second, A plus B is equal to B plus A. But how do we know this is true? Let's use some counters to help us identify this. So I have 3 red counters here. 1, 2, 3. And I also have 4 blue counters. In total, we are going to have 1, 2, 3, 4, 5, 6, 7 counters. 7 counters. And this is us using 3 red counters and 4 blue counters in the order of it being 3 plus 4. So, what if we did something different? How do we prove that the commutative property is true? So, now we're going to move our 4 counters. We have 4, 1, 2, 3, 4 in blue, and then we're also going to have 3 in red. Notice how the roles reverse. We had the 3 red, and then we have 4 blue, and now we have 4 blue and then 3 red. This also equals 7. If we would have changed it and it was 3 were blue and 4 were red, it still would have been 7. For our last question, number 4, we're going to be using manipulatives to explain why addition is associative under the set of numbers. So, what is associative property? Associative property means that the way numbers are grouped together does not change the sum. But how else can we explain this? So essentially, we have A plus B are going to be in our parentheses, and we're going to add C to the outside of parentheses, and then it's going to equal A, and then inside the parentheses is going to be B plus C. But let's go ahead and use some counters to see with the numbers 2, 3, and 4. So we are going to have 2 and 3 inside of our parentheses, and they are also going to go inside of our circle. And then on the outside of parentheses, we are going to add 4. So I have 2 green counters, and then I'm also going to add 3 red counters. And then on the outside, like we have above, we are going to add 4. And I'm just going to do these in blue. And so for the parentheses or our little circle there, we have 5, and then we are going to add 4, and that is going to get us to 9. That is the main problem. We know 4 plus 5 or 5 plus 4 is equal to 9. But how else can we show this? Let's break it down a little bit more. So now we are going to be doing our 2 little counters over here on this side. 1, 2. And then on the other side, these are going to be the same color again, guys. I'm sorry, but we are going to do 3. And of course, 2 plus 3 is going to equal 5. So now we're going to add 4 more. Let's see here. We are going to add our 4. We have 1, 2, 3, and then 4, 5. And then on the other side, we are going to add our 4. And then obviously this is going to get us to 9. Notice how we got 9 up top for our original problem and 9 at the bottom. So now we're going to be doing some regrouping. So the last two numbers, 2 plus 3 plus 4 inside the parentheses. So on the outside, we're going to have our 2 little blue counters. And then on the inside, we're going to go ahead and do our 3 counters. And then we're also going to add our 4 counters in there. We have 1, 2, 3, 4. And I'm going to do these ones in red just to kind of help us out a little bit. And that is obviously going to bring our answer to 7, and we're going to put that. And so 2 plus 7 is obviously going to equal our 9. And then now we are going to be doing 3. We have 1, 2, 3, and we're going to add 4 to this one. 1, 2, 3, 4, and we're going to go ahead and color these in. And like we already know, because we've done this one a little bit, 3 plus 4 is going to equal 7. So what if we add 2 more? So we are going to notice how we had 2 7s, 4. Earlier we had a 5, and now we have a 2 plus 3, and we have another 9. All of these numbers we are just reusing. But what if we did add that 2? So now we have our 2, 1, 2. We're going to color those in, of course. And then, oh, I don't know what just happened right there. And then on our other side, whew, bear with me, we're going to have 7. We have 1, 2, 3, 4, 5, 6, 7. So we have 7, and then we have 2, and then when you add those together, of course, we're going to get 9. So, what does this mean? We have 9 and 9 again. And then we had 9 and 9 over here. So, the total for both of our little examples here was 9. So that means that this addition is going to be associative. It doesn't matter how you group the numbers, it stays the same. So what did we learn today? We learned a couple things here. So, first thing, a natural number starts with 1. It starts at 1. And then whole numbers, we're going to remember this, it's going to start with 0. It's all natural numbers plus 0. And then again, I'm going to put my little line through it just so that we know it's 0 and don't get confused later. And then the set of a whole number is closed under addition. We learned that one down in question 3, and I got a little lazy, so we have our little words here. So the cumulative property means that you can change the order of the numbers when you add. An associative property, the associative property means you can change how the numbers are grouped. And the sum will stay the same, of course. And thank you so much for following me through all of these questions today. I hope you learned something new today. Thank you and have a good night.